Hello, ladies and gentlemen. All right, today we are going to continue to talk about the ellipse. Now, as a reminder, the ellipse is very similar to our circle, but remember, unlike having a radius, an ellipse can either have a major axis that is vertical or horizontal. Whichever direction the major axis goes, that is your A value, and then your minor axis is your B value. The other thing to keep in mind that may come up a couple of times today is this calculation for eccentricity, which is C, so that value towards the focus, either focus, that length, divided by A. All right, so we are going to be in our notes and we are going to be starting by continuing to practice converting to standard form. So remember, the conversion means that this equation right here given to us is in general form. And to get to standard, the way that we are going to go about doing that is that we are going to complete the square, okay, for each of the quadratics in our equation. Now, as I've mentioned before, we want to identify our same variable terms. So like we've got 36x squared and positive, we're going to end up with positive 48x. We want to get them in the same set of parentheses. So 36x squared plus 48x. And then I have my y values, which I'm going to rearrange by adding the 9y squared over. So I'm going to have a second set of parentheses. So that's going to give me 9y squared minus 36y. And then the 43, I'm going to move to the other side, so I'm going to subtract that. All right, so now that I have everything all organized, I am going to take out any a values. So in the case of the y's, that's pretty straightforward because when I take out the 9, I get y squared minus 4y, and then I can fill in my blank with our C value, which is going to be 4. And so then I can add 36 from the 9 times the 4. Now with our x terms, this is going to be a little bit trickier because even though 36 isn't a GCF, we are still going to divide that 36 out because we need our leading term to be 1x squared. And so what we are going to end up with is a fraction that we're going to have to divide by 2 and square. So just as a reminder, we want to simplify that as much as possible. So we're going to end up with 4/3 of x plus something. And so remember, we're taking 4/3 and dividing it by 2. So that's the same thing as multiplying by 1/2 and then squaring. So we are going to get really 2/3 that we're squaring. Right, because 4 and 2, that's going to simplify. So we're going to get 4/9. And then the nice thing is we're going to multiply that 4/9, that value, by 36. So we won't end up having to add a fraction. We're going to add 16 to the other side. Okay, so when I go to complete the square, I'm going to have x plus 2/3 squared, because remember that value is b divided by 2, plus 9 times y minus 2 squared. And then we are going to be equal to, I believe that's 9 on the right side. And remember that because we want an ellipse, we want the right-hand side to be equal to 1. So we're going to divide everything by 9. So our final answer, because I'm going to have a little bit more space over here, is going to be x plus 2/3 squared over, I know this is going to seem a little weird, over 1/4. Because it has to be in the denominator. So since this is 4, I have to divide by the reciprocal. Oh, sorry. and then y minus 2 squared over 1. You don't necessarily need the 1 if you don't want to have that, and then that equals 1 on the far side. So I know that that looks a little funky, but that's like as funky as that could possibly look, folks. Okay, and so that helps you figure out your a value and your b value for your ellipse. All right, moving along, there is a second problem here that I'm going to give you some time to pause and convert this to standard form, so same exact process we just used. And then remember that your eccentricity, C, is equal to, E is equal to C divided by A. So take a moment and convert this, and then when you unpause, the work will be there, and then we'll talk about how you evaluate that eccentricity. All right, ladies and gentlemen, so the first thing I did was I separated each of my variables, followed that whole completing the square protocol. I remembered to add 2 values based on multiplying them by their a value. And then I got this equation right here. From there, I pulled the a value out by taking the square root of the larger denominator. And then I used the c squared equals a squared minus b squared formula to find c. And then I put those two things together, and I got e equals 1/2. Now, what does that mean? It means this is kind of oval in shape. It's not super, super ovally, not very elliptical. In terms of its stretch, right? To be highly eccentric, you want to be much closer to 1. You want to really have the c value and the a value be closer together. Okay? So this is not very oval in shape. If you were to stretch it out, you would see that the width and the height are pretty close. It's closer to being a circle than it is to being an ellipse. Okay. Now we've got another problem in which we need to find an equation of an ellipse with a vertex equal to vertices at 0 and plus or minus 8, and then an eccentricity of 1/2. So I'd like you to, again, take some time to try and find that equation and sketch the ellipse on your own, and then check in with your answer when you unpause the video. Hey, ladies and gents, welcome back. So as I finish up making my ellipse graph, hopefully you can see that I started by graphing my vertices points, and so that gave me my center, which was right here at 0, 0. And then that let me know that the a value was 8. And so I was given the ratio for the eccentricity of 1/2, but since the a value wasn't 2, it was 8, I had to set up this little proportion. C over 8 equals 1/2, and then I got that C was equal to 4, which allowed me to figure out what b squared equals, and so I was able to come up with this equation over here. And then to finish graphing, I had to draw the minor axis, so I had to figure out what b equals. And since the square root of 48 is pretty close to 49, I figured that the width of my ellipse was around 7. And so that is how I finished sketching my ellipse here. So there you go. And keep in mind, if you wrote x minus 0 and y minus 0, that's totally fine, but you don't have to include those zeros. All right, moving along to a little bit of an application problem. So if you've ever been to the U.S. Capitol building, you may have been in Statuary Hall, which is the Whispering Gallery. It's called the Whispering Gallery because it's an elliptical room. So I'm going to sketch an ellipse for us. Oh, that is not a great ellipse. Let's see if I can maybe make a slightly better one using my circle tool. There we go. Okay, so it's an elliptical room that is a grand total of 46 feet wide. So I'm going to do this. I'm going to make that 46 feet and 97 feet long. And the cool thing about this room is that wherever the foci are located, because of the nature of an ellipse, if you whisper at one end, your whisper will bounce off and it will land directly at the other focus. So you could whisper, whisper, whisper something, and only the person standing in the other spot across the room will hear you. Super crazy cool, right? So some things we have to do in this particular problem. First, we have to cut each of these distances in half, okay? Because those are going to be our A and our B values. So, and I'm going to leave the 97. You know what? I think in this rare case, I'm going to give us a decimal. You know how I don't love those. So 48.5 over here, that's our A value. So we want to write an equation first, and then we want to find the distance between the foci. Okay, so the other thing we are trying to find is this distance, which I know doesn't look equidistant, like to the left and the right of our center, but just bear with me on that. It's not 100% exact. Okay, first off, to make our lives way easier, we can make the major and minor axes our x and y axes and make the center 0, 0. You don't have to do that, but like, why make it harder than you need to? So to write our equation, we have all the information for that ready to go. So we'll have x squared over 23, I'm sorry, not 23. X squared over, and really, like, it also doesn't matter so much. As long as your drawing matches what we're about to write, we're good. So I'm going to write 48.5 squared plus y squared over 23 squared equals 1. So because I drew mine horizontally, that's why I made the x the major axis. But if you drew it vertically, I think that would be equally fine. So this is one of those times where it wouldn't really matter which direction you made your major and minor axes. Now, either way, we need to take 48.5 squared and subtract 23 squared, and that's going to give us c squared. So this is definitely a moment where, yes, we're going to get out our calculator, and we're going to evaluate this. And so I'm getting 1823.25 is equal to c squared. And then I'm going to take the square root of that answer. And now I'm just going to write down the approximate value because I don't want this as my answer. This isn't my final answer, okay? Because just like the major and minor axes, I need to double this because that is going to be the distance from one F point to the other, right? It's going to be 2 C's. So I'm going to take that value and I'm going to multiply it by 2. So the distance that we are ultimately looking for here is 85.399 feet. Right? Because we're in feet. Yes. So think about that. You could be 85 feet, a little bit more than 85 feet from somebody, and you could whisper and they could hear you. That's pretty neat. All right. You've got another problem, little different. You've got the area of a circle with r equals 10, center at 0, 0, is half the area of an ellipse with vertices plus or minus a, comma 0, and a minor axis of 20. Find the length of the major axis if the area of an ellipse is a equals pi times ab. So I'm going to give you a moment to try this problem on your own, and then I will reveal the answer. Before I let you loose on this problem, though, I do want to remind you of one last thing. So this is in your notes packet, and this is a summary of all things ellipse. So as you prep for your next assessment, you want to make sure you know all of these variations and pieces of information so that you fully and completely understand this shape in the same way that you know the parabola and the circle as well. All right, so back to this problem. I'm going to pause. You try and figure this out, and if you get stuck, unpause, and you'll see some work here for you. All right, folks, as we close things out for today on the ellipse, notice that I have some various work as I work through the information we were provided. First, I wrote down the area of a circle formula, plugged in r, figured out the area of that circle. If the area of that circle is supposed to be half the area of our ellipse, I doubled the area of our ellipse to figure out that value. And then I was able to determine that a times b would be 200. And so if I know b, because I know the length of the minor axis, I can figure out a. And then from there, that allows me to finish things off. Since the length of the major axis is 2a, And so I get a grand total of 40 units. And that was the last thing we needed to figure out. Thanks so much for sticking with it and listening. Have a good rest of your day, folks. Bye-bye.